Okay, today we'll go with continue with transactions only, but in that we'll be seeing acid properties in transaction. Understood? Acid properties in transaction. Now see, the problem here is, again, this is a concept. Okay, so first you have to understand this concept. First, the problem here is we have to break down a lot here. What we have to break down, that is the terminology now. First is what is acid, what is acid properties, and next is what is transaction. So one by one I have to make you understand this subject. Once I make you understand this subject, next I have to explain you how this solution is got from Java. So always in cluster we go on teaching you what? Concepts. Once you understand a concept, getting the output is very simple because it is there in the library. Understood? But most of the institutes, they will not teach you concept, they will only concentrate on what? Output. So we have a different methodology. So concentrate on the concept of this. Okay. So once we complete the concept, next we'll be seeing what is the output of it. Okay. So clear? So see this. So here, one we have to understand what is the concept. We have to go with two things here. One, we have to understand what is concept, means what is acid properties. It's a very general subject and related to what? Transaction. Transaction is a subject which is purely related with database. Okay. Next, you have to see solution from Java. So that will become the next subject. Solution from Java. And your solution from Java will be always what? Very simple. Okay. So let's understand the subject. And this is one of the most challenging subject which every application developer faces. Very challenging subject. And very few of them understand this. Even they might have 2 years, 3 years or 4 years of experience. But very few people understand this subject very clearly. Understood? So let's see it actually. So first I'll be going with the concepts and then I'll be talking about the solution from Java. Okay. Almost all 50% or 80% of the class I'll be only talking on what now? Concept. Till then you don't even think about Java. Leave of Java now. Finally you'll be seeing the solutions in what? Java. Finally. Understood? Fine. So now to understand that concept, first we have to understand what is transaction. Then I'll come back to what is acid properties. So one by one we have to break the terminology now. There are terminologies. Understood? Yes. Last class we saw what is a transaction. Transaction means, you know, there will be a table in the database now. Supposing you can have account table and you can have account number, name, salary, balance, anything like this. Some columns you will have, account type, more you can have. Understood? Just I am mentioning 3 columns here. 101, 102, 103. Name is AA, BB, CC. 1000 rupees balance, 2000 rupees balance, 3000 rupees balance. I got a simple table now, and this table has been kept in the database now. Clear? So now actually let's again revisit and see the meaning of what is transaction. Okay. So in transaction means what happens? See, your application will be receiving what? Request from the user interface. So user will be filling values and he'll be submitting, like enter amount, okay, enter account number, like this. Whatever values he wants, he will fill and submit all the values. Enter account number, enter amount. If you want to transfer and all that, example I'm telling. So you'll be giving these values into your application. So what should your application do now? Take those values. Okay. See, your application is receiving values now. 1 from the user interface, 2 from the database. So like that your application will start receiving values and they'll come dynamically. Right now we are still going with hard-coded way. Later on it will be coming dynamically. So once you get the value, see, some values you'll retrieve from what? Database also. And then you'll start writing the logic. So writing logic is very, very easy now. Please understand that. Writing logic of an application is very, very easy. Only the problem here what we face is how do you bring values into application, how do you fetch values from the database. So like this we face problems, and once you retrieve also, how do you hold them. Okay, that is whether you use data structures and all that. Again we'll come back to that subject, but once you receive the values, what you do? You do a series of database operations. Okay, you do a series of database operations, and obviously you'll be writing code like this. Try, okay, so, and you'll write all your queries now. Try, catch. You catch your exception. In Java we are seeing the solution. So here what you do? Yes sir. You'll write operation 1, operation 2, operation 3, like that many operations you'll go on doing. So first understand what is a transaction, then we'll understand what is acid properties. I'm repeating it. Understood? First understand clearly what is transaction. So see here, supposingly I am not doing a transaction now. Supposingly I am not doing transaction. Transaction means what? Performing a series of database operation as a single unit. If you don't do it as a single unit, every query, okay, means operation 1 means it is nothing but what? One SQL query. Understood? It's one SQL query. So by default what will be happening now? Every SQL query it will execute. And it is making changes to the database and it is saving the changes also. If you don't run it in a transaction, what is the problem? Every query is executed. It is making changes in the database and also saving means committing. So by default auto commit is true. So operation 1 executes, makes changes, commits. Operation 2 executes, makes changes, commits. Operation 3 fails. So 2 operations have happened, but the 3rd and 4th operation has not happened. So now what happens? If it doesn't happen, it will come to the catch block. All that is okay. But in your database, you have got invalid data. Now if you have got invalid data, it's one big headache, one more big subject now. Somebody has to sit and maintain the database now. What they have to do? Sit and clean up all the invalid data. They should remove. Understood? So, and all those problems will come. So you are not writing an application to maintain database now. Yes or no? You want everything to be solved with the application itself. Okay, either all the values should be entered. If any value is saved in the database, it should be valid data. You don't want invalid data. So these are the things. So that is why it's better we do this in a transaction now. So how will you do the transaction now? Just say con dot set auto commit, disable the auto commit. That's it. Transaction begins. If you disable the auto commit, transaction has begun now. And always the transaction should end with what? Commit or rollback. So here, if everything is successful, I'll say con dot commit. And now what will I do? If it fails anywhere, I'll say rollback. Understood? So now what is happening? First query executes, makes changes, but it is not committing. Second query executes, makes changes, but it is not committing. So like that, it will not go on, means it will be making changes, but it will not be committing or saving. Finally, when everything is executed successfully, it is going to commit. Means now all the queries will be treated as what? One single unit. It will be treated as one single unit. Earlier they are treated as separate unit. Understood? So this is the actual meaning of transaction. Generally, the first problem in this terminology is many people think transaction means what? Withdrawing money from ATM. That is their problem. So when you are having that logic in your head, and if I say I am doing a transaction, now you will be only observing what there. Where I am withdrawing money, where I am transferring money, only that you will be observing. But fact is, the logic means here what queries you are writing will only be different. I might be inserting, I might be deleting. Correct? No. So that is what we mean. Transaction means what? Running a series of database operations as single unit with all or nothing criteria. First understand the meaning. So I understood this terminology. Now what is transaction? Because next I have to go with what? Asset properties. Are you getting it now? So first understand, it's either all or none. All the queries should execute or none of them should execute. It might be, see, this one case I gave you. Another case we might be inserting records into 2 or 3 tables. Multiple tables. So you want the data to be inserted in all the tables or none of the tables. Yes or no? So that's also a transaction. Now there I am not withdrawing money only. Yes or no? According to you, transaction means what? If I ask you what is the meaning of transaction, explain transaction means, the first statement what you will be telling is, I'll go to the ATM center, I'll put my ATM card and I'll withdraw the money, that is transaction you will tell. Or I'll transfer the money, that is transaction. Transaction means there a series of operations will be happening. If all the queries execute, means as one unit, then we call it as transaction. That is the actual meaning of transaction. Are you clear with the first terminology? Clear this? Now we have to come to what? Asset properties. So it's a big subject. Okay. So see, transaction is a big subject, but solution from Java is very simple now. So transaction is a big subject, but solution comes from what? Library. In Java we don't code anything. Unfortunately, there's a problem here. Understood? People think Java language is difficult, vast. Understood? The answer is, what I give is, Java is very simple language which can be learned in 30 days. Rest all, after completing the language, we are learning libraries. Because so many problems arise in coding an application, Java is giving you only solution to coding that application. Obviously library is vast now. Don't tell language is vast. Language is very, very simple here. 20, 30 days the language will get over. So here we concentrate on learning what? Libraries. So how good and patient you are in learning the library, that better applications also you can write, and that better logics also you can write. Understood? It's a vast library. So Java language is not vast. Only library is vast. Good only no, because we don't have to write what? Logics. But in other language also is complicated. They have their own syntax, own style of coding. Apart from that, no library, you have to sit and write everything. Think of doing this operation in C, C++. Just think. It is bit complicated. Bit complicated what? It will take what? Nearly 5 days, 6 days, 7 days. Understood? So that much of complication is there in coding this concept with many languages. But Java is giving you easy solutions to this. So learn Java like this. First concept, then the solution from Java. So until unless you are not clear with the concept, there is no way you can understand Java. Because people think generally, I want to code Java, they start seeing the Java file. And when they don't know the library, they will not know what is happening only. You will never understand which method I am calling, what I am doing there. So that is the actual problem people face in learning Java. They have been not guided properly, and they come and sit with the old concept of what? Int I is equal to 1, int j is equal to 2, int k is equal to I plus j. That is the logic what they think which has to be written. But that is not the fact here. We write these kind of logics. Understood? So first be clear with the concepts, then we will be seeing the solution from Java. Are you clear with the full transaction concept now? Are you clear with the full transaction concept? Next we will move into what? Acid properties. Okay, again, if I say, do you know acid properties? Yes, you will definitely tell what? Yeah, I know acid properties. As A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. Like that only you will tell. Understood? That is your problem, but you know the meaning of it. What is it? Okay, full form you know. But exactly what is atomicity? What is exactly consistency? What is exactly isolation? What is exactly durability? That is what I am going to explain to you now. Clear? And this is one of the most challenging subject. Even very high level application developers do not know. That's one of the most unfortunate thing you can say. But the fact is, if I make you understand now, it is a very challenging subject, but it will become very easy to you once I complete that subject. Okay, so as soon as I complete that concept, then I'll explain you how it will be done in Java. Clear? So I'll be going to the next one now, acid properties. Okay, so yes, as I told you, acid stands for what? So if you do a transaction, see if I complete the transaction, we say it guarantees what? Acid properties. That's what we say. That's how that statement will be built. If you apply a transaction, you will get the acid property support. If you don't do a transaction, you lose that support. This. Understood? So if you do a transaction, they'll ask you in interview, why do you do a transaction? Understood? What is transaction definition? You know now. Transaction is nothing but doing a series of operations as a single unit with all or nothing criteria. What is transaction? No. But why do you do a transaction? Okay. So because if you do a transaction, you get acid properties support. But what is acid now? Yes, you told full form, you know. A stands for what? Atomicity. It is a shortcut, or they say acronym. Okay, it is the acronym for all this. Atomicity, consistency, isolation, and D stands for durability. So if you do a transaction, you get all these four now. If you do a transaction, all these four you will be getting it now. Understood? So see, a transaction subject which I taught you just now about the database, it is purely related with database, and you saw that support has been given to you by the technology. Which technology? JDBC technology. Fine. In fact, this transaction subject was somewhere entire this concept was introduced way back in 1980. Means it is purely related to database, and now we are saying how to do it with Java language. So whether you write an application in C, C++, VB or whatever it is, you have to do a transaction. Understood? So almost for 50 years of history it has got, but we are only seeing the solution how it has been done by Java. Okay. Now see, again in 1980, whoever invented it, he said if you do a transaction, you'll get all these four. Understood? But the question is, what is atomicity now? What is consistency? In depth, we have to see. One by one, we'll start seeing now. Clear? So, we'll be seeing the first one, atomicity. Atomicity I have already explained to you. Okay. What is the actual meaning of atom? Once again. See, these points are already written yesterday itself, or the last class. What is transaction? And the transaction will end either by doing commit or rollback. But this point we are discussing today. When you implement the transactions properly in the application, it guarantees ACID property. So we are going to the first one, atomicity. Yes. So first we'll go with atomicity now, the first one. Okay. Now in atomicity, first let's understand the meaning of the word atom. Atom means what? It is the smallest unit. Yes or no? The smallest unit what we know is atom. The same word is applicable here. You know, you are good in English, you should be able to understand all this now. Understood? So here we are having many operations. Yes or no? Try operation 1, operation 2, operation 3, operation 4. You can have many operations and you'll have catch, exception E. Now the same concept now. All these 4 units should be treated as what? One single unit. That is what is atomicity. Treating all the queries as one single unit is only called as atomicity. It becomes one unit now. So treating all the queries as one unit is only called as atomicity. See this definition. Getting it now? So atomicity guarantees that multiple database operations will run as one atomic unit with all our nothing criteria. That's it, simple. Understood? Now if all our operations in the unit, atomic unit are successful, then transaction is successful and committed, and if any operation in that unit fails, then transaction is failed and transaction is rolled back. Clear? For example, if you are transferring funds from one account to another account, then you need to perform many operations. One of the example I am taking. Okay, atomicity guarantees that all SQL queries will run as a single unit with all our nothing criteria. Understood? So now see, I am going with the next one. That's all about which one? Atomicity. Consistency is also very easy like this only. Durability is also very easy like this. Only the little challenging subject to learn is isolation. And all this by default it's happening for you. You don't have to worry. ACID properties, it's a huge subject. But if you do a transaction, you're automatically getting what now? Atomicity, no? We are not even writing any extra code for getting what? Atomicity. Just I'll begin the transaction now, automatically atomicity is happening for you. What brilliant solution from Java. Understood? So if you begin the transaction itself, atomicity is guaranteed. So we have completed atomicity. Now I am stressing, clearly understand now. See, ACID properties, as I told you, is a very challenging subject. You will not find the notes for this in many places. Okay, you will struggle, but you will not be able to find the answers for the meaning of what is ACID properly. But I just got around 5 to 6 pages of document here. This document is very powerful and it has been built with my 10 years or 15 years of experience, whatever you take. Understood? So, and with my expertization, I am bringing you this subject of ACID properties now. So concentrate, otherwise you will never get this subject anywhere in your lifetime. Means you will struggle to understand this. Is atomicity clear now? So I will move to the next subject called as what? Consistency. I am moving with what? Experience. Concentrate now. Yes. Consistency ensures that by the time the transaction ends, we are going to the next one now. Consistency. Very powerful document. Okay. Consistency ensures that by the time the transaction ends, whether successful or not, okay, there will be only valid data in the database and all the business constraints are applied. All the business constraints should be applied and only valid data should be stored. Understood? Now what is the meaning of that? We'll see it step by step. Supposingly, see, I'll have one table now. Account number, name, balance. Here I'll set on constraint. Always balance should be greater than what? 5,000. I'll set on check constraint. So once I set the check constraint, now here always data should be what? More than 5,000 only. So assume that I got account number 101, 102, 103. 10, okay, then name would be A, B, C, 1,000, okay, set 10,000, 20,000, 30,000. Now I have set a constraint. Now I want to transfer from this account to another account. Okay, so when you're doing anything like this, okay, what happens now? So like I will do multiple operations now. Operation 1, okay, by default executes and commits. Second operation executes and commits. This is how it goes on executing. But operation 3 fails because of what? Constraint problem. Now the data inserted here is invalid data now. The data inserted in the, means whatever has happened in these two operations, insert or update, whatever has happened is invalid data. We consider that as invalid data. So that's what we say. Okay, even when you are executing queries like this, if by chance your your query fails to execute, your query is failing to execute because of what reason now? Some constraint problem. Okay, because if it fails, okay, once it fails, we should see to that even these two queries are not getting executed. Yes or no? These two queries also should not execute now. The reason is what? Because this has failed. So for that to happen, you have to run this in what now? Transaction. For that to happen, you have to run this in transaction. So just say con dot set auto commit false. That's it. Now consistency is automatically got for you. So Java people are taking care of everything here. You're automatically getting what now? Consistency also. So it's a huge subject. But solution from Java is what? Very simple. Either all the queries should execute, means atomicity will help consistency. Atomicity is in turn helping what? Consistency. Okay, if all queries should execute or none of them should execute. Atomicity. Consistency means what? If any constraint fails, understood? Then none of the queries should execute. So both are working together. But for achieving that big subject, all I did was what? I begin a transaction, I end the transaction. And are you clear with this now? Okay. So anyway, begin and end of transaction is called as what? Boundary of transaction, which I discussed yesterday. Boundary of transaction, or it can end by doing try, catch. It can end by doing what? Rollback also. Con dot rollback. This is also called as what? Both are. This is one boundary, this is other boundary. So transaction either end by commit or by doing rollback. Yes or no? So we got consistency also. Understood? By default everything is happening. We are not even writing any extra lines of code. So that's what we say. When a transaction is being applied, if a transaction is applied, we'll always see to that only invalid data, okay, is going to be stored in the database. That is nothing but consistency. Consistency means all the rules will be applied and none of the rules will be changed. Consistent. The database system remains consistent during the process of transaction, and we'll see to that all the business rules are applied. Understood? So that's the meaning of consistency. See, consistency ensures that by the time the transaction ends, whether successful or not, if it is successful, fine, it will be valid data. Unsuccessful, it will roll back. Still it is valid data, no, previous state. Understood? But we don't want in between state. So that's the meaning. Understood? So successful or not, then there only be valid data in the database and all the business constraints are applied. If a transaction successfully executes, okay, if a transaction, clearly see the point, if a transaction successfully executes, it will take the database from one valid state to another valid state. From one valid state it has to move to another valid state. Clear? Next, if any errors occurs in a transaction and it fails, next what? Then any changes already made will be automatically rolled back. Yes or no? Any changes have happened, that should be rolled back. Now why it should be rolled back? Because the transaction has failed. Understood? So this will return the system to its state before the transaction was started. The actual meaning is, see, it means that a database administrator won't need to clean up any mismatched data from the operations that failed to complete. So all your business constraints will be applied. How many constraints are there? Primary key constraint, foreign key constraint, check constraint. Okay, whatever constraints are there, all the constraints will be applied. Clear? Example for that. This is an example for what? Check constraint. So let's define a rule that says balance column in account table should be greater than what? 5,000. Okay, so before the transaction it is 6,000. Before the transaction it is 6,000, and let us say it has become 8,000. Then it is left in a consistent state. Before the transaction it is 6,000. After the transaction it is 8,000. Fine. Then it will commit. No problem. But if it falls below 6,000, let's say 4,000, then it has to be. It is considered inconsistent state. In which case we will roll back the transaction, and this point, none of the queries will be executed. Clear this now? None of the queries will be executed. So that is what we'll either have valid data or no invalid data. Only valid data will have, that's guaranteed. Understood? No invalid data problem only here. Fine, next. Now see, this is an example for what? Checked constraint. Check constraint. Now this is an example for what? Second one. Primary key and foreign key constraint. So you should be good in database to understand all the subject. Clear? Fine, see this. If a DBMS allows fields of a record to act as reference to another record, means primary key, foreign key concept, then consistency implies the DBMS should enforce referential integrity, meaning by the time any transaction ends, each and every reference in the database must be valid. Every reference should be valid. Primary key should be referring to foreign key to primary key. All that relationship should be applied by the time the transaction completes. Otherwise, none of them should happen. Are you clear with this? Fine. In fact, yesterday I showed you one constraint. The size constraint or something I showed, now 5. If it is more than 5, what was happening? One example I gave. Roll back. The phone column was what? The size of the phone column was 5. I was trying to insert a phone number with what? 6 digits. That time what was happening? Roll back. If I insert a phone with, see, this is on table now. Try doing this. This is on table. Employee. Any table you want to take. In that, by chance, if I am having employee ID, name, phone. Size of phone is what? 5 digits. Try to insert a phone with 6 digits. It will fail. Understood? Clear this? So that is nothing but what? Constraint. So all the business rules will be applied. Either all or none. Clear? But I showed you in 2 tables. That's it. Here I wrote it in 1 table. There I showed you in 2 tables. Because when you do it in 2 tables, you have to write many queries. Clear? Fine. Next. So consistency clear? Okay. I'll go back to I'll finish off durability. Then I'll come back to what? Isolation. Because durability is also very simple. Okay. So first we'll go to durability. I'm going with the D option now. See, durability ensures that, okay, first the meaning I'll teach you, then I'll come back to this point. See this, you'll be having your program. You can have your program now. It can be in any language, secondary, and this is your database. And you're doing some operations now. You're doing operation 1. Operation 1. Con dot set auto commit false. Fine, and you start doing the transaction. Operation 1, operation 2, operation 3, con dot commit, fine, catch, exception E, then you'll say con dot roll back. Fine, perfect. So now see, all the queries have got executed. Let's see on the problem here. See, this program is in computer 1. This one different computer. Understood? This can be in a different computer. Computer 2. I'm just creating scenarios and to make you understand what is the meaning of durability. Okay. So now say your program is running, all the queries are executed successfully, commit has been issued, commit has been done, and you'll give back the response to the user. What? Yeah, successfully done, congrats, or whatever it is. You're giving the message to the user now. You transferred money or whatever it is, or if he has become a member to your application, you'll give off the message. You have issued commit also. So commit has been issued from the program to the database. But by the time this query gets executed, there might be a network failure. Yes, the database might crash. Yes, power failure might happen, and this database might shut down. Anything can happen here. There are many problems. You think practically now. Okay, so I just created two, what is that? Computers to make you understand it. Even if the database is in the same computer also, what might happen? Your program is a different, program is a different entity, database is a different entity. Your program has issued commit, but by the time the query is gone to the database and completed the execution, anything can happen. Power failure can happen, understood? Database can get corrupted, whatever it is, okay, or a network failure might happen, anything can happen. So now, what about that now? So means the data has to be durable, we say. The meaning of durability means it should be durable. Durable means what? Exist, persist for long amount of time. Data should not be lost. Okay, by default, if you don't do a transaction, your data will be lost. Your data will be definitely lost. If you don't do a transaction, data will be definitely lost. Okay, if you do a transaction, data will not be lost. If you just start the transaction, end the transaction. That's it. You see, for achieving atomicity, consistency, durability, in Java you will not even call on extra thing. Just you begin the transaction and end the transaction. Automatically you are getting what now? Atomicity, consistency, durability also. Here also I will explain the durability concept. But by default you are already getting what? Durability support. So let's see how it happens. You are understanding how it should exist. So what happens? See, supposingly I begin the transaction. Supposingly I begin the transaction. Once you begin the transaction, the database what will be happening now? To see to that the data is not lost, if you begin the transaction, then only this happens. Okay, so first query executes. It is making changes in the database. It is making, but it is not committing. It is not committing because we have started the transaction. That is okay. But it will be maintaining some log file, we say. One log file. Log file means it is one place where all the details will be logged. What is happening, what is not happening, and all that. So same information, whatever changes has happened, it will be logging into one file now. Next query executes. It is making changes and that is updated in the log file. Like that, it will be keeping one extra copy. Understood? So by the time you issue commit, and now that has not been committed to database, power failure happens or whatever happens, and you have told the user successfully done, and tomorrow user will complain. And means the amount is not being transferred or something like that. Something he complains. Understood? That time you can go to the log file and get all the details. Details means what? Whatever changes that happened, that you can get. Now what you have to do, you can read that value and then update it into database. But data is not lost. So it is durable. Understood? So this is one of the mechanism database people use. One database vendor will use one style for doing what? Durability. But many database vendors use the concept of log file. Okay, some might write it into one more backup table. One database vendor has got one methodology. Understood? One more backup table they will keep and they will be writing into one more table now. So if anything happens, it will be there in that table. Some database vendors prefer to write it in what? Log file. Some people will write it normally into some other storage only, physical storage. So leave that. But end of the day, if your transaction is committed and it is not saved in database, that information you can see it here and you can update the values. By chance, if it is committed now, what will happen to this log file? Automatically it is deleted. It will be deleted. There is no use of it now. Anyway, the changes happened in the database now. Because how many queries will be running now? And that log file will become very huge. So what they will do? Once the transaction is committed or rolled back, either option, that will be deleted. Which one? That log file. So that is what you mean by durability. Data is not lost at any cost, provided you do a transaction. If you don't do a transaction, God only knows what has happened to your data. Query executes, and data might be lost. Understood? So if you do not want your data to be lost, better you do it in a transaction. And how do you achieve durability now? Just begin the transaction, end the transaction, automatically you got all the three now. What? Atomicity is guaranteed, consistency is guaranteed, durability is guaranteed. Clear now? Hardly we are writing any logic, and all the three are by default happening in Java for us. Means they have written the means why it is happening in Java like that means they have written this logic already in their library. We just call the method con.set.commit false, con.commit, con.rollback. They have written all that logic. You do not have to worry about that. Otherwise, if the support was not there, doing all this would have been a very big headache for us. Understood? No? So that's what I'm telling. It's a vast subject, a challenging subject. But in Java, developer does not have to worry about anything. Understood? So learn Java like this. Instead of directly looking into code and trying to understand what is there in the code, first you understand the concept, next you'll understand the code. Clear this? So are you all the three concepts clear now? Isolation is very challenging. Understood? So I covered atomicity, consistency, durability. And all of them you'll get just if you set the boundary of transaction. That's it. Are you clear? Once the transaction completes, this log file or whatever it is, it will be deleted. So this is what you mean by durability. So database is one very vast and challenging subject and very interesting. Okay. And that is what I taught you. Formature is perfectly required for your application point of view. I covered database. Perfectly I covered. Now see this point now. Durability ensures that any transaction committed to the database will not be lost. Understood? Once the transaction is completed, the results of the transaction should be made permanent so that they'll survive any sort of system crash, power failure or network failure. I showed you two computers. It might happen in the same computer also. Just for you to give better clarity, I did that. Understood? This typically involves by using transaction logs. Understood? Transaction logs in the database server or by storing the results in some other form of physical storage. Means somewhere they'll be keeping on backup copy of whatever changes are happening in the transaction. Any changes that will be maintained. And tomorrow if anything you feel that the complaint comes tomorrow, customer will complain. That time simply go to the log file and you can trace out all the details and update that value into the database. Clear this? Yes. Last comes isolation. Clear this? So we are moving to the last part of acid properties. I am teaching it in A, C, D. Now I'll come to I now. Yeah? Yes. Isolation. Okay, first understand the meaning of isolation or isolate. It's purely related with Englishmen. Okay, isolation or isolate means what? Isolate means separate. That is the meaning. Isolation means what? Separation. Now what has separation to do with transaction, you might ask? Or what is the meaning of separation in transaction? Very interesting subject. We'll see this. For understanding isolation, you have to understand something called as a concurrency problem. When you are doing transaction, there are sometimes you might face something called as concurrency problem. So again you'll ask now, what is concurrency? So these are all terminologies. One by one I have to break now. And then I have to make you understand what is this concept. So I have to understand all this now. What all I have to make you understand? What is isolation? What is concurrency? All that I have to explain to you. Then I have to explain isolation concept. Then I have to explain you how it is solved in Java. This is the subject. So let's see this now. So first let's understand concurrency. Concurrency means what? Many things meeting at the same point. Yes or no? Many things meeting at the same point. Concurrent. All meeting at the same point is called as concurrency. Okay. So yes. Now what is that got to do with database or transaction? You might ask. Yes. Again let's see that. So I'll take the same account table. There's an account number, name, phone and balance. Like this you can have your table. or this table is there in the database. Fine. Till now we are writing a program. This is a Java program. Okay, or you can write your program using any language. But see now, when you connect to database, right now we are assuming the scenario that only one user is interacting with the database. Yes or no? But later on we'll start developing applications where multiple users will use your application. Understood? Like Yahoo, Rediff, Gmail. How many users are using the application at the same time? Many people will be using it. Understood? And that is only the current trend in the market today. Understood? So means we develop something, some applications in such a way that multiple users will be using the application, same application at the same time. Same. It is not that after I complete using in standalone application you have a problem. In standalone application what happens? Your application, understood, and your database are all in the same computer. So one user has logged in, till he completes using the application, another user cannot use that application only. So if you develop such kind of applications, today you can't improve your business. Understood? So that is the next subject what we are going to see, Servlet. Servlet is going to give you full-fledged solution for what? Accessing your application or writing web applications. In web applications what happens? Your application is only one now. Understood? It will be kept somewhere in a server or something. This is your application now. Okay. So all the users will be accessing what? The same application. Now for one user will keep one database. Huh? No. Generally you'll have only one database. Yes or no? Now this is where concurrency problem starts now. Understood? And today we develop these kind of applications only. Why you know? If you want to do good business, okay, you have to share data. Without sharing data, you can't improve business only. Understood? So this subject we'll be discussing in depth what is web application. That is secondary part. We'll be seeing web applications in Servlet. But let us come to the meaning of what is concurrency. See now, multiple users have logged into the application and all are accessing the same table. There's a possible chance that one user is depositing the money. Say he has logged in and is depositing the money. Okay. And at the same time, one more person is one person is A is okay, let me take like this. For C, money is getting deposited from A. At the same time, C is retake. Yeah, he is also depositing. C is also depositing. Means both are accessing the same account at the same time. Understood? Two people are accessing what? Which account now? C only. Means it is concurrently they are accessing now. They are accessing the database what? At the same time. So this is what is meant by concurrency. Okay. So when this concurrency happens, you understand the problem of concurrency. So this will give rise to many problems. Three major problems it will give. And those three problems are called as dirty read, repeatable read, and phantom read. This is the most important interview question. Which one? Isolation. Most important interview question. Even if you are having 2 years of experience or 3 years of experience, your interview is not going to be complete with what? All these questions on transaction. You might go as a fresher, or 1+ or 2+ or 3+. These questions are going to be 100% for you. Understood? So no interview is complete without the questions on what? Transaction. Why? Because without transaction you cannot write your application only. So all these are very important. Okay. So when a concurrency is happening, there are three kinds of problems you will face. Dirty read, repeatable read, and you understood what is concurrency. And when your concurrency is happening, means all the people are accessing what? The same data at the same time. Same data at the same time. That is the problem here. Okay. So when that concurrency is happening, there are three kinds of problems we face. Dirty read, repeatable read, and phantom read. Now again you'll ask me what is dirty read. That's what I'm going to explain next. So first you'll understand what is the dirty read problem. then we'll understand what is repeatable read problem, then we'll understand what is phantom read problem, then we'll see the solution from Java. Clear this? So this is a totally different subject. Okay, so now I will explain you all these three problems when a concurrency happens. So that is why what we do when concurrency means when during a transaction we isolate. See, your concurrency understood now. We have to isolate means when one user is using the data, okay, do you want to share that data, same data with other user or not? You'll isolate, you'll separate it. One transaction should not affect what? Another transaction. So that is what is the meaning of isolation. So isolation is only a solution to what? Concurrency. Isolation is a solution to transaction concurrency problems. Understood? Now what are the different transaction concurrency problems? Those three. Clear? So we'll see this now. I'll clear straight one by one, because in this table only we can't explain. One by one I'll explain you all the separate things now. Dirty read, repeatable read and phantom read. See, this is a very important table I will write now. Write it properly. In one table only I will cover off everything. Or better is, till I complete writing this table, you don't write. After I complete only you write. See this now. Make a dirty read. Read into three places. This will be a repeatable read. Then we'll see phantom read. So first, say I'll have one table here. The table name is going to be called as account. We're having account number, name, phone, and balance. Is your table. And now see this, there are two transactions which will happen now at the same time. Understood? So transaction 2, what it will do, it will say update. You know how to write the queries? Write it, just understand the concept here. So update account set balance is equal to something like 55,000, where account number is equal to 101. Understood? So what is transaction doing now? It is making changes. Yes sir. So this is your query or operation 1. This is your operation 1. Done? So obviously this will be changed to 55,000. It will overwrite. Now transaction 1 starts using the data. Concurrency problem. Understood? Means see what it will do. Transaction after that has been done, it says select balance from account where account number is equal to 101. Where account number is equal to 101. So what value it will get now? 1000 or 55,000? Obviously changes have happened. So it will get 55,000 only. And it will start using the data. Okay, it will start using the data. This is operation 1 for transaction. Means concurrency is happening now. Understood? Now what this transaction will do, some problem happens and it will roll back. Now what happened? See, no problem. Now this is using 55,000. Fact is there is only 1000. So transaction 1 was reading what type of data? Uncommitted data. Transaction 1 was reading what data? Uncommitted data. So reading uncommitted data is only called as dirty read. That's it. Understand concepts. Reading uncommitted data is only called as dirty read. This is concept. Solution I show you. Understood? First understand the concepts. So whenever a transaction reads uncommitted data, that data is said to be called as what? Dirty read data or dirty read. Clear? Are you clear with this? Okay. Now this has rolled back. 1 second. Just I'll write it on top. Correct only. But understand that this already got the value. First this happens. See the process here completely. Then what happens? This one happens. Then what happens? This one happens. Clear? Or I'll use some reading. It will be more clear for you. So first this query got executed, then this query got executed, and then this query got executed. Done? Fine. So next solution is, the solution, what database people say is, if you do not want dirty read to happen, that's what they say. If you do not want dirty read to happen, what you do is lock the column, they say. They say lock the column. Means until and unless that lock is released from that column, nobody else can use that data. Even if concurrency is happening, what will happen now? Transaction 1, if transaction 2 locks the table, if transaction 2 locks the column, transaction 1 cannot read the data only. It cannot use the data. So until and unless transaction 2 completes the execution, either success or failure, that is secondary. Until and unless transaction 2 completes the transaction, okay, transaction 1 cannot use the data only. Means the data is not shared now. Understood? So option is you can lock the column. Understand the concept, sir? Understood? This is your option. So this has made changes. See, transaction 2 has made changes. Transaction 1 is using it. To avoid that, what you do? Just lock the column. Okay, fine. So you understood the concept, but how do you do it in Java now? That's the question. Simple. There is one constant. All these constants what I am teaching you now, understand, it is present in the interface called as connection. In connection interface there are constants. I am exploring the library now. We are seeing the library support of Java. There is one constant. If you send that constant, means if you use that constant, automatically what happens? You will solve this problem now. So the name of the constant is, in JDBC, or I put it in broad way, in Java. Okay. Solution to dirty read problem is, first I'll write, solution to dirty read problem is what? Solution to dirty read problem is lock the column. Getting it now? That's the general solution. In Java next, or in JDBC Java, we use the constant transaction underscore read underscore committed. This constant you have to use. And how you will be writing the code is, I'll just put it on top. I'm not having space here. Here I'll write, yes. You'll say, shall I write it here in between? Okay, see this. You'll do it like this. Con dot set transaction isolation. You'll call this method now. You'll call this method. There's a method in connection. Once you say con dot auto commit false, as soon as you say con dot auto commit false, you begin the transaction now. After you begin the transaction, call this method set transaction isolation and pass this value now. Which one? Transaction underscore read underscore committed. Now where is this? It is there in the interface called as connection. Connection dot transaction underscore read underscore committed. That's it, over. Your dirty read problem will be solved. Means if you call this method now, the application is putting a lock now. Your program is running now. See, user has made a request. Your program is running. So what will your application or program do now? It will put a lock onto the column. That's it. And if another transaction comes, concurrency is happening, still you don't have to worry. What a huge problem you had, and you have solved it with what? One simple method and one constant. Brilliant solution, no? So that is the solution is given to you by Java now. Clear? First the concept, then the solution. So next I'll go with what? Repeatable read problem. Understood? Are you clear with this? Fine. In repeatable read problem, what happens? I'll take the same table. Account number, name, phone, balance. See, this is again transaction 2. What it will do? It will select some record. Let's see how it selects. This is operation 1 now. Okay, first this side transaction 2 is getting, means this transaction is getting executed. When I say transaction 1, transaction 2, don't think that is executing first, this is executing. Two transactions are happening at the same time. Understood? So that's what you have to understand. Operation 1. So here what happens? Yeah. So I'll be telling select, oh no, I'll update it. Transaction 2 updates. Update, same thing. Account set balance is equal to 55,000, where account number is equal to 101, and it will commit. This time it is committing. This time it will be committing. Now transaction 1. Okay, I will do one thing. We'll go with this first execution first. Select. Assume that transaction 1 got executed first. Select balance or star. Select star. It's selecting the full row. Star from account where account number is equal to 101. So here, you know what values it has got, 101 and all that. So first it will get some values. This is operation 1. First this will execute. Then what will happen? This will execute. It is committed. It so happens that sometimes the same transaction will be executing the same query again and again. It goes on repeating. Means your logic will be like that. First you will want some values, then again you will need some more the same values, and again you will need the same values. So many times you will be writing the same query. Oh, I'm not having space here. Okay, so again what happens? After that has happened, again transaction 1 continues. Select star from account where account number is equal to 101. So first this got executed, then that query got executed. Now this query gets executed. So this time it is reading a committed value, but previously it had got some values, but this time it is getting some other value. It is reading committed, but first time when you wrote the logic, when your logic was getting executed, your logic was using what value? The value of 1000. First time it was using the value of 1000, but second time you are getting a value of what? 55,000. Not only that, see, this is transaction 2. I'll have transaction 3, one more transaction now. Many transactions will be happening. It will update what? Update account set phone number. Phone is equal to something, it will change 1, 2, 3, 4, where account number is equal to 101. It has changed the phone number. So now see, transaction 1 updated this. This transaction updated, then transaction 3 is updating what? phone number. So again, one more select will be done now. This is fourth query which is getting executed, but they are from different transaction. This is from transaction 1, this is from transaction 2, this is from transaction 3. Like that, all are using the same data. Now again, select star will happen. Where account number is equal to 101. So this time phone number will be getting what? 1234. Here one number what you had got? 111. These were the values what you had got. So every time you go on reading, you are getting different value. How you write your logic now? Understood? So it means here also see transaction 1 is going with many executions. Here it will execute this, then it might have some other operations, operation 2, operation 3, operation 4. Then after that it will execute this query. Then again it will perform some more operations, operation 5, operation 6, operation 7. Then again it will execute this query. Like that transaction 1 is executing. Meanwhile other transactions are updating the values on the same table. And it is committing also. But your transaction 1 is ending up reading what? Committed values only. Everything perfect. But the problem is, every time you read the value, you are getting different values now. Because it's committed value what you are reading. Understood? So this should not happen again. Okay, anyway, this problem is called as repeatable read problem. This problem is actually called as repeatable read. Repeatable read means fetching different values in every read. Every time you go on reading, every time a transaction goes on reading the values. One transaction goes on reading the value now. Every time it reads, it will be getting different values now. So again what you could have done, you could have locked the row. So until unless one transaction completes the execution, other transaction cannot do what? Anything with that data. So this time what you do, for solving repeatable read problem, you lock what? Full row only you do now. So here what will you do? Lock the row. That is a solution from database. Now how will you lock the row in the database? One constant is there. And the name of that constant is solution. See solution, I'll write here. Solution to a repeatable read problem is lock the row. Understood? So and how will you do it? In JDBC we use the constant. What is the constant? Transaction. See, this is very important interview question. Which are the different constants you will use to solve the different concurrency problems or isolation problems? Understood? Transaction underscore read committed. The next one which I am showing is what? Transaction underscore read underscore, sorry, repeatable underscore read, I think. It's there in the document I'll be showing you. Transaction underscore repeatable underscore read. Use this one. And how will you do it? Same method you call. When you begin the transaction, con.set auto commit false. After that, you call this method con.set transaction isolation, and only value what will be giving is what now? Where will I write that method? I'll write it here. Con.set transaction isolation connection dot what now? Transaction underscore repeatable underscore read. Just call this method, that's it. Understood? So use this, automatically which problem will be solved now? Dirty read problem. It will put a lock. If you see, end of the day your program is going to interact with database. So when your program executes this method, it will put a lock onto the row now. Finished. You have a problem and see the solution. And problem was so huge. Solution is so simple. Are you getting it now? So last we'll go with what now? Phantom read. Same table I'll take. Fine. Now there is one transaction. What it will do? It will go on inserting. Insert into. See this. Okay. First this transaction one will execute. First transaction one will execute. What it will do? Select star from account where balance is greater than 1000. So how many rows you will get now? 2 rows are retrieved now. Because I want the balance which is greater than 1000. Fine. Next. What will transaction do? Second. You see these queries are getting executed now. Transaction 2 is happening now. So what it will do is, it will say insert. Insert into account values 104 DD 444 4000. So it will insert. One more insert it will do. Insert into account. Like that it will go on inserting some records. Means assume that on admin is adding the values. Okay. So 104 EEE 55 5000. Like this is adding records. One more will insert. Insert into account values 105 sorry 104 105 106 FF 66 6000 means some phone number. So I'll update the values. See this. So 3 rows have been inserted. 104 105 Yes, sir. So then again, see this is operation 1, this is operation 2, then next, third one. Transaction 1 again executes. So again what it will do? Select star from account where balance is greater than 1000. So this time how many rows will have? 5 rows. So 3 rows are extra, no? Extra or not? Yes. So first, for understanding phantom read problem, understand the meaning of phantom. You know English now? Yes. What is the meaning of phantom? Ghost. Yes or no? Yes. First read, only 2 were there. Next read, what happens? 3 are coming from nowhere. Yes or no? So it's like something like ghost now. Yes or no? So that is what you mean, phantom read problem. Phantom read means fetching extra records. The solution to this is what? Lock the table only. That's the solution. So for solution for this would be lock the table. Means until unless one transaction completes it, other transaction will not use it. This one now. Okay. Like this you can solve it. So and now solution. See the solution, be careful with the solution. This is one solution. Here this is the solution. Here this is the solution. Solution is what? Lock to solve. To solve phantom read problem. Lock the table. It's a very huge subject. Understood? See this now. So what we'll do in JDBC, which constant I'll use now? Use the constant, which one? Transaction underscore serializable. That's it. Full table will be locked now. Again think practically. User has made a request, your program is running now. That time what will happen? When your program is running, it will lock the full table. If another user makes the request also, table is locked. He cannot insert or do anything. He has to wait. Until the first transaction, means until this transaction completes, the transaction has to wait. Understood now? Yes. So like this, locking the row, column or table will solve all your problems. You got the solution. Database people are telling do this. Java is giving support to that. Understood? Now, from a practical point of view, we'll see. Is it advisable to lock the column, row or table? Question comes now. Because see, if you do locking like this, aggressive locking we say, what will happen? Other transactions have to wait now. Now see, no transaction can use a table only. This table has been locked. What will happen? The user has to keep waiting now. So what will happen? Obviously, performance of your application goes down. So aggressive locking can degrade the performance of your application. So that is why what we application developers always prefer is, we prefer to go with only solving dirty read problem. We want only dirty read problem to be solved. We don't want these two problems to be solved, because many times, even with my experience, I'm telling, okay, there will be always cases that you want only this problem to be solved. These two very rarely will come across. Okay, and this by default, database people, the vendors are there now. They are only putting this lock now by default. Which one? Means they are giving you by default. Most of the database people, they are solving your dirty read problem. So you don't have to worry about that also. So what you will do? Con.set.commit false, con.commit, still nothing you are doing, because database vendor is by default doing what now? Putting that lock. Whenever one column is getting used in the transaction, database people are only putting the lock. So why should we application developers put the lock now? Understood? So that I'll explain you very clearly later. For time being, you understand there are three kind of problems, and the application developer needs the solution for only which problem now? Dirty read. Because aggressive logging can degrade the performance of your application. The user has to go on waiting, and no user is going to wait for too long today. Yes or no? 2 seconds he doesn't see the output, what will he do? He'll start using some other application now. So aggressive locking should be avoided. Anyway, these are the different concurrency problems. And to solve those concurrency problems, we should do isolation. Yes or no? We have to separate. That transaction should be separated from this transaction. So that is why these three constants what you are seeing are called as transaction isolation constants. These are called as transaction isolation constants. But it becomes a very important interview question. What are the different transaction isolation constants? Name them and explain the different problems solved by them. Very simple question. Answer is also very simple. Transaction underscore read underscore committed solves dirty read problem. Transaction underscore repeatable underscore read solves repeatable read problem. Transaction underscore serializable, it is not visible, I'll write it again. Serializable solves phantom read problem. Clear? Serializable, man, nothing else. Anyway, document is there, you can refer to that. Simple. Java solution to all your problem is very simple. So that's what, understand concepts. Coding in Java is very simple. Are you clear with all this now? Got the table? Lock the column, lock the row, lock the table. Clear? Shall I clear everything now? And see, these are subjects which you will learn with experience. Most of your freshers, hardly you know what is database. Yes or no? If I ask you what is database, you will tell I know database. Have you ever come across all these problems? No, you don't know database only properly. So when will you understand database properly? When you start developing applications, when you start interacting with applications, when the application starts interacting with the database, then you will come to know everything about all these problems. So once you come to know about all these problems, then you will need solutions. So until and unless you understand the problem, there is no question of what? Solution. So see the problem, understand the concept, then Java gives you the solution for that. Clear? In fact, many people working in industries do not know this. They might be 3 years of experience, 4 years of experience. It's an unfortunate thing, but facts have to be accepted. Understood? Facts have to be accepted. Now, how can I and you ignore it. As we'll start off with the I property now. So it's a huge subject, but developer is again doing nothing for what? Isolation also. Be careful with that now. You're doing nothing to achieve what? Atomicity, consistency, isolation and durability. Still the same three methods only you're calling. What? Set auto commit false, commit rollback. Nothing you're doing. And isolation I'll explain you more. Okay, then we'll conclude the topic. Isolation. Yes, we may have one or more transactions running concurrently. Yes or no? We may have one or more transactions running concurrently which may access the same data at the same time. Multiple transactions should run without knowing each other. That is, the transaction should be isolated, okay, from one another. Note that isolation typically involves locking columns, rows or tables in the database. Okay, essentially, who is going to put the lock now? The question is that transaction manager. The transaction manager puts the lock onto the, means see, one option is, this is a very important subject. Okay, let me clearly explain you now. See this. I'll be coming back to this point again. See, you have a database and you have an application. One option is you can put the lock on the database table from program, whichever program you are writing. Okay. Second option is you can put the lock on the table in database. You have got options here. You can manipulate. It means there are some settings. If you do some settings, changes in the database, you can put lock on what? Column, row or table. But by default, database is putting lock on what? By default, the vendor, when he gives you the database, he will be putting lock on most of the cases. Default lock by DB vendors will be put on columns. To solve what problem? Good. To solve dirty read problem. Default. Most of the DB vendors. Okay. So if you want, I can change the settings in database now. Now that is better or this is better? Changing the lock in the database is better or changing the lock in the application is better? Think. Changing, you got two options now. Okay. We developers prefer to put the lock on application side rather than making the changes in the database. Because if you make the changes in the database, it will affect the whole application. Any changes, any settings you do here, it will affect the whole application. I do not want that to affect the whole application. There will be hardly one method or two methods which will need that isolation. In your project now, you will be writing a huge project. Like example, save employee, one method. Okay, or save customer. Anything you can take. Then one more method you can have, transfer money. Example I am giving. Understood? So you might need some isolation level here or you might need some isolation level here. One method you'll need. It's a huge project now. Only for that isolation for a particular method, why are you making the lock on the table in the database? Only do it here. Understood? So before you begin the transaction, what do you do? Con dot set isolation level, con dot set auto commit false you will do now. This you will do because you have to begin the transaction. Once you begin the transaction, next what will you say? Con dot set transaction isolation and pass that constant. What is that? Connection dot, I don't have space, I'll continue. Which lock you want? Okay, that you can put. Now transaction underscore serializable. I'm locking the table. And do your operations. What? Operation 1, operation 2, operation 3, do it. Finally say con dot commit. So as soon as you commit, the lock will be released. Transaction completes now. So this is much ideal. We prefer to put the lock on what? Application side rather than putting the lock on table in the database. Because that will affect the whole application. Any changes done here will affect the whole application, which we do not want. Understood? So that is why, see, DB vendors, they know that by default always dirty read problem only is the major problem for what? Application developers. So when they supply you the database, I'll be showing you for MySQL and Oracle that what is the default value and all, I'll be showing you. Understood? So what they do is by default they'll be setting it as transaction underscore read underscore committed. Default they'll be setting transaction underscore read underscore committed. If you do not want that, then you change it in your program like this. If you do not want that lock, I want to increase the lock now, or I want to increase the isolation level, then you change it where like this, and that will be effective to only one method. Okay, otherwise you will not call this method only now. If you are happy with solving dirty read problem, what are you doing? Nothing you are doing. So you will continue to code with what? Same three methods. That is more than sufficient for us. So you do not have to worry too much about isolation also. So nothing we are worrying. Atomicity we are not worrying. Consistency we are not worrying. Isolation we are not worrying. Durability we are not worrying. Just if you begin the transaction and end the transaction, all the four is guaranteed for you now. Yes or no? So either it will end by again commit or with rollback over. Are you clear with this concept now? This is a very important concept. Either put the lock on the table in database directly or do it from your application. Yeah? Shall I clear everything now? We'll go to the document now. Again I'll come back and explain this to you very clearly. Yeah, so in JDBC, so now see, depending on one persistent technology, every persistent technology, like we are studying JDBC now. In JDBC, connection is the transaction manager which helps you to put the lock. Understood? Connection is a transaction which helps you to put the lock. In Hibernate, if you are using, there you will have a different transaction manager which will help you to put the lock. If you are using Spring, there you have a different transaction manager which will help you to put the lock. So in one technology, you will have one class, one method like that. Understood now? So we are studying from JDBC point of view how to do isolation. How to do isolation using JDBC technology. But see, if you understand this concept, whether you are doing Hibernate or Spring or whatever it is, only thing is one method or some argument will be varying. Rest all concepts will be same only. Understood? So that is why to learn advanced technologies, it is very easy until and unless you understand this basic concepts. So advanced technologies are powerful libraries, nothing else. They are very powerful libraries where still more coding is reduced for you. Here coding is reduced to one level, no. There it will be reduced to more simple level. That's all about advanced technologies. Clear? So let's continue. We may have one or more transactions running concurrently which may access the same data at the same time. Multiple transactions should run without knowing each other. That is, a transaction should be isolated from one another. Note that isolation typically involves what? Locking columns, rows or tables in a database. Essentially, the transaction manager, who is a transaction manager connection object in JDBC, ensures that nobody touches your data while you are in the transaction. If you increase the isolation level, connection object will take care that nobody else will touch your data. Done? Next, usually isolation is provided by using what? Low level database locks hidden away from the developer. Okay, the transaction manager places some kind of lock on the database, data accessed by the transaction, so that no other process can modify them until the transaction is finished. Simple solutions now. Understood? Yes. Transaction concurrency problems. Very important interview question. What are the different transaction concurrency? Write it down. This is very, very important. Interview question. Many people will go for what? Interview, but they will not get job. Reason is what? These are definite interview questions. They are not reading the definite interview questions, but simply they will go for what? Interview. Waste it is. So perfectly note it down. What are the different transaction concurrency problems? First problem you understand. When many users are using an application at the same time, then they may access the same data at the same time. When multiple transactions are sharing the data in the database, we may get inconsistent results because of the following transaction concurrency problems. What is the first one? Dirty read, repeatable read, phantom read. Done? So fine, we'll go with the first one now. Very clearly explained here also. What is it? See, dirty read. Very simple. Here I have shown you in a different table. That's it. A dirty read allows a row changed by one transaction to be read by another transaction before any changes in the row have been committed. Before it is committed, it will read. See this. Transaction 2 is updating something. What it is updating? It is updating users table. Update users. Set age is equal to 21, where ID is equal to 1. It has updated. Meanwhile, what is that transaction doing? Reading. Select it is doing. What will this do? Roll back. It is adding invalid data. This is dirty read. Simple, I am explaining in document. Clear? Are you clear with this? Understood the dirty read problem? Point wise, it is very simple. Next, repeatable read. Is also very simple. Repeatable read is where one transaction reads a row. Understood? A second transaction or alters or deletes the row and commits. That is very important here. It will be in repeatable read, you will be reading committed data only. Understood? But every time you read, you will get a different value. Understood? So, and the first transaction rereads the row, getting different values the second time. And the data will be different. This is usually done due to another concurrency transaction updating the data between the queries. To solve repeatable read problem, we have to apply lock on the particular row. Okay, for previous one you have to apply lock on column. It is there. Just see this. I didn't read it out. To solve dirty read problem, you have to apply lock on the particular column. Okay. Yes, we'll come back here. Repeatable read. Yes. So see this. Here you have selected same query, but here this user has updated. He has committed. But next time you read, you'll get what? Different record. If you do not want this to happen, lock the row. It will solve your problem. Understood? Next will come phantom read. A phantom read is where one transaction reads all the rows that satisfy a where condition. A second transaction inserts a row that satisfies the where condition. And the first transaction rereads the same condition, retrieving the additional phantom row. Phantom means earlier it was not there, but suddenly it has come. It's something like ghost now. Okay, that's the thing. In the second read, to solve phantom read problem, we have to apply lock on the particular table now. So let's see. Select from star from users. Users is the table I am using here. Select star from users where age between 10 and 30. Next here, see what happens. Insert into user values. One row has been inserted and committed. Select star from users. The same query gets executed. You'll get the extra row now. That is the phantom row. Yeah. So to solve this problem, you'll apply lock on the particular table. Simple. Yeah, transaction isolation levels. So it's used to solve concurrency problems which might occur during a transaction. An isolation level defines how much a transaction can share the data with other transactions which are running concurrently and are trying to access the same data. However, perfect isolation, if you want perfect isolation, you can get it. Nobody can touch the data. But what will happen? Can affect the performance. You can get it. Okay, because it often involves locking rows and sometimes complete tables in the database. We do not want that. We little want to share data. Understood? So that's why aggressive locking can hinder concurrency, requiring transactions to wait on each other to do their work. Realizing that perfect isolation can impact performance, and because not applications will require it. All applications will not require that kind of what? Isolation. Very rare it will happen. Very require it. Okay. But solution is there. If at all you require, you should have a solution in Java, no? Solution in Java should be there. Otherwise what they'll tell? Java is not having a good library. Complaints will come, no? So Java gives you the solution to solve that problem. But we don't use it. Practically you understand. Support concept is there, problem is there, support is there. But finally, practically what we are going to use, that also you understand. Yeah? So that's it. Because it's desirable to be flexible. Yes, to solve the above discussed transaction concurrency problems, we can use one of the following transaction isolation levels. All are static final constant variables present in connection interface. First I'll show you the connection interface. See this. See, it's very simple. You got all these constants, what I showed you. These constants you use. And they are int constants. What value they'll be having? Integer value. I'll show you what value it contains. Understood? See, read underscore committed. A constant indicating that dirty reads are prevented. If you use this, dirty read will be prevented. Non-repeatable read and phantom reads can occur. These two can occur. Now, uncommittedly, repeatable read indicates that dirty read and non-repeatable reads are prevented. Means some documents you will see non-repeatable read, sometimes they will say repeatable read, but the concept is same. Phantom reads can occur. Here two problems are solved. If I use serializable, all the problems will be solved, but performance will go down. Understood? So these three constants we'll be using. Clear? Uncommitted means it will have all the problems. Uncommitted. So by default, database people are giving you which solution? This solution. Understood? None means transaction only is not supported. Generally, all database support what? Transaction. Otherwise, you'll never use a database only. And how do you find out the information about the database now? Database metadata. If you want any information, what is the default isolation level, all that, you can find it out. I'll be showing you now. So anyway, these are the constants. The same constants I am explaining in my document, nothing else. So that your English is very good. Since you don't follow it there, I am putting it in simple English for you. Understood? Simple. Allows you to read the changes that have not been committed, may result in what? Same thing. Dirty read, phantom read and repeatable read, because it is uncommitted. And this 1, 2, 4, 8, what you are seeing here, they are the integer values. So you can say con dot set transaction isolation 2, or this one, we'll come to that. Understood? So anyway, these are the constants you can use, or you can go with this name only directly. I'll be showing you that. Next, allows reads from the concurrent transactions that have been committed. Go through it, the same points are it is. So it is explanation. Now one more table I'll give you, which will finally put the nail into the coffin, and clearly you can understand all the solutions here. The different same it is, below that table only it is there. The different isolation layer constants present in the connection interface and the different concurrency problems solved by them. If you use this constant, none of the problems are solved and there is no lock. Understood? But concurrency level is very high. This is the concurrency level now. More it is. Done? If you use committed, it will only solve dirty read problem, but not these two problems, and it will put the lock onto the column. Repeatable read will solve only two problems and it will put lock onto what? Row. This will put the lock onto the table. So here concurrency is less and there it is more. Understood now? Just an arrow mark indicating that here concurrency is more, here it is less. Concurrency more means what? They can access the data. Less means what? It is locked, you cannot share the data. That's it. Fine? So this is about the table. Remember this table now? Yes. How do you set isolation level in JDBC? How do you set it? The method. I'll show you now by coding, I'll show you. But see the methods now. Or first I'll show you, then we'll come back to all these question and answers. Definitely asked in interview. Yeah? How do you do it? How do you do it? They'll ask. So what I'll do now is, yes, we'll take this program. But remember, I'll show you, but nothing you'll do, man. Atomicity, consistency, isolation, durability, all is happening for you by default. That is why you do a transaction. If you don't do a transaction, you lose all these four things. Understood? See this now. How do you set the isolation level? Okay, fine. I'll take this test project. Okay, there I'll code. You can code it in, or you create a new project and do it. In test project means get the connection, that is first. Install and close. All this is not required. Initially I'll show you the value of the constants first. I was telling you the value as 1248. See it for yourself. So you have to use the constant connection dot transaction underscore uncommitted. then transaction underscore I want committed. Then next I want to print what? Repeatable read. No? Transaction underscore repeatable read. You're expert in that now? Semicolon and closing. Okay. Transaction underscore serialization. Done. So let's print the values. They are constants. I showed you in the document. See this? What are they? Int, no. Static constants. Errors. Where errors? Okay, these exceptions will not occur. Huh? Catch. Okay, we are not loading anything. Nothing will happen. So all this, I'll do one thing. I'll enable this. Otherwise, I have to remove again all that. Yeah. Concentrate on what now? Only these 4 lines. Here, exception will not occur. Just printing the constants. No. See, what is output you are getting? 1, 2, 4, 8. So, when you are setting the transaction isolation level, na, see this, we understood this now. Understood. So now I got the connection to what? MySQL. Okay. First, let us see what is the default isolation level. Let us see what is the default isolation of what? MySQL. So it's very simple. If you want to find out the default isolation level, you don't have to take the database manual and study now. You got what? Database metadata interface. Now it comes usage. Okay. Database metadata encapsulates the complete information about what? Database. Let's see. Database metadata. See here. Be careful. Huh? I pressed enter. But which class? This is a class present in what? com.mysql.jdbc package. I don't want that. You have to choose which one? This one. So be careful. So here you can see it as imported from there. Delete it. Okay. And use from JDBC package. Java.sql package. dbmd is equal to con.get metadata. Finished. Now I'll print sysout. Yes. dbmd dot get default transaction isolation. Call this method. So what it will give you? The default isolation level of database. That's it. Concepts you know now. You are only finding it. You don't have to take the manual and read everything now. Whatever information you want about database, you can get it from database metadata. So I commented everything now. See all this. So here you'll get a value now. See, I put a statement. MySQL isolation level is plus, getting it now? Let us see the output. 2. 2 means what? Committed. Simple as that. So next, I want to change now. Okay. Are you clear with this now? So now, if I want to begin a transaction, what I'll be doing? Generally we say, generally, see, once I get the connection, I show you for Oracle also. It is 2 but, okay. Fine, next, con dot set transaction isolation. Call this method. Con dot, sorry, before this, what you have to do? One second, we'll come to this. You want to begin a transaction. Con dot set, sorry, auto commit false. Done, and I'll make it as false. You begin your transaction. Then you change your isolation level. By default it is 2. Where? In database. So what I'll do now? I'll say connection dot, I want to increase it. Which one? Either it will be repeatable read or which one? Phantom read. Only 2 you want to solve. If at all you want to solve repeatable read problem, press it. Over. Now do your operations. You can write your queries. operation 1 means write your queries, whatever queries you want, operation 2, and finally you will tell what? Con dot commit. Done now, and you will roll back. That's it. Okay. So fine, you can send the value like this, or you can directly send what? 2 4 1 2 4, no? 4. This is also correct. But who will understand what is 4 doing here? So that's why we use constants. If you look at the constant name, it will be very clear, no? It is solving this particular problem. So that's why they give you constants. This is also working. But nobody will understand what is 1 2 4 8. They can't by heart. But you can remember this definitely, which one? Repeatable read. It will solve repeatable read problem. Done? So like this we can do it. Okay. Are you clear with this now? Let's see the transaction level of what? Oracle default. Okay. And this is how you can find set it. And if you want, I can get current isolation level now. It has been changed now. For this method, assume that I am writing all this code in save employee method or transfer money method. I want to find out the default one. Con dot get, I think transaction isolation. We are seeing, see, dbmd dot see, dbmd got this one. If you call database metadata, it will give you the isolation level of database. But if I say get isolation level, it will give me current isolation level. It has been changed to what? 4 now. So if you want, you can check what is the current isolation level. I am just showing you methods, man, nothing else now. We have understood the concept. We are only seeing the library now. Directly, if I had showed you out this output, what you would have understood? You wouldn't have understood anything. Understood? So understand always the concept. So let's see. Once again, current isolation level is. These are very important methods asked in interview. Getting it? What is it? Current isolation 4, because I changed it now. So these two methods of connection interface, set isolation, set transaction isolation, get transaction isolation. Set transaction isolation is used for increasing the or setting the isolation level. Get transaction isolation is used for getting the current transaction isolation. Done? Fine. And if you want to find out the isolation level of database, then which method you will use? Get default transaction isolation. That is about the database. Database metadata. Done? Okay. Are you clear with all this now? So let's find out what is the default isolation level of what? Oracle. Same thing you do here. Where? I have done it for Oracle. Now first program I will take. There only I will print. Okay. See here. Extra. We have so much of code. Now see, the driver is what? Oracle driver now. So now we will connect to what? Oracle. I will comment everything and just print only that. One second, I will copy from there only. I have to import it. Con.get data means metadata. I will print now. My Oracle. I will just change this one. Oracle isolation level is 2. Means it is solving dirty read problem. So this is your interview question. I am not showing you simply for time pass and all that. What is the isolation level of MySQL? What is the isolation level of? Because if you say you work with some database, they will ask you what is the isolation level. Understood? So whatever I am covering now today are all interview questions, which will be asked not to you when you go to interview today. Even after 1 year or 2 years or 3 years of experience, you will be changing companies now. That time also this interview question will come. 100%. Why? Because if you go to interview, they will ask you questions from the library only. From where they will ask? They have to ask you from what is existing. They cannot ask you interview questions from non-existing things, no. So library is limited here. If you understand the library, it is going to be very simple now. Are you clear this? Okay. So you saw how rich the Java library is now. Understood? So let's go back to the questions now. These are, I put it in question answers now. Simple. How do you set isolation level in JDBC? In JDBC now we are discussing. By using the set transaction isolation level method present in connection interface. You know how to do it now. Understood? How do you get the current isolation level? Just now explained. Get transaction isolation level method. How do you find the default isolation level? By using this method present in which one? Database metadata interface. Then next, what is the default isolation level of Oracle database? The default isolation level of Oracle is 2, which means transaction underscore read underscore committed. So this isolation solves only dirty read problem. You want that, you have already got it. Understood? Even for MySQL it is true. Now imagine developer asks for so many things and you have been provided with so many solutions for coding your projects. Unfortunately, people are not understanding these many solutions are there for the developer and they end up writing what? Applications. That is a problem. Understood? So you got excellent solutions. Library support is there, brilliant libraries are there, database is there. What you want? You want to develop an application? No. Everything is there. Only learn how to use it. And for coding also excellent editors are there. Like what? Eclipse and all that. What more solutions do you need? So without, see, at the beginning of the course, I'll come to that. Okay. We'll finish this. So durability, done. Now some more questions are there. This I covered yesterday, transaction management in JDBC. I showed you only the output yesterday. But today I went on to explain you what is ACID properties in transaction. Okay, so you do not have to worry anything in transaction now. Simply what I taught you in the last class, continue doing the same and all this will happen to you. It's a huge subject. I told you at the beginning, it's a very challenging subject. Okay, but we don't have to do anything in Java. But from interview, you'll get questions. How will you do this? How will you do that? Questions will be coming. Understood? So this I covered in the last class for you. Transaction management in JDBC. All this I covered. This transfer, I explained to you all this. Local, flat, fine, nested. Yes, some FAQs on JDBC transaction. Okay. Why do you do a transaction? What happens if you do not do a transaction? Interview question. These are not my questions. Clear? Fine. A transaction guarantees ACID properties, and if you do not do a transaction, you lose the ACID property support. Next, how do you begin a transaction in JDBC? They'll ask you like that. Understood? In Hibernate, you'll have a different methodology. Spring, there's no standard. So you should always remember when you put your when you build your resume, you'll be putting on project. In that project, you'll be mentioning your technology. Understand how the interview is built actually. Simply I'll go for interview means no, you should be able to defend your resume. They'll not ask you anything outside. Supposingly in your project you have mentioned you have used JDBC as a persistent technology. So they'll ask you everything from JDBC point of view. Supposingly if you mention Hibernate in your project, they'll ask you everything from Hibernate point of view. So all your interview questions are based on your own resume. Clear? And if you don't clear, don't blame them because they are asking you right questions. Problem is you don't know it. So carefully follow now. So this is a very important question. When you say that, you know JDBC. Understood? Or if you tell you have done a project on JDBC. How do you begin a transaction in JDBC? You know how much important transaction is. Then definitely this is a highly valid question. So we do it by what? We begin a transaction. I gave you this answer yesterday itself by calling set.commit false on the connection object, con.set.commit false. This statement disables the auto commit and starts the transaction. Simple. And you'll get what? All the 4 ACID properties. What more do you need, man? Excellent support. Understood? Who is the transaction manager in JDBC? Connection object is a transaction manager in JDBC. Next, what are the different transaction concurrency problems? I explained you full thing, but answers are very simple. See here. You don't have to remember everything now. Question and answers are given. But if I tell you all that, now remembering this is easy. Otherwise, what will you do? By heart. I do not want you to by heart anything. Understood? So what are different transaction concurrency problems? Dirty read, repeatable read and phantom read. How do you use the transaction concurrency problems? Sorry, how do you solve it? By using the various transaction ISO level constants present in connection interface. Lastly, what is transaction isolation level? A transaction isolation level defines how much a transaction is ready to share the data with other transactions which are running concurrently and are trying to access the same data. Yes. Which are the different transaction isolation level constants and where are they present? You know this for, and it is present in connection interface. Remember this. For your lifetime you remember this. Not today, tomorrow interview. Lifetime you have to remember this. So important they are. Next, where will you have the boundary of transaction? Yes, this will be understanding by experience. It will be there in the service layer. Clear? So such a, see, now cluster takes a different approach of training. Okay, most of you might have come from other institutes completing what? You will tell I know JDBC. But these are all mandatory things which you should know in JDBC. So in cluster we don't teach output. Clearly understand. Other all institutes go on what? Teaching output. But here we do not teach you output, we teach you concepts. Once I teach you the concept, output getting output is secondary for you. That is not primary because you know how to do it. But all institutes train you in doing what? Output. Means you start by hearting. So we take a different methodology. We know it is going to be challenging, but at the end of the day, you will become a good software engineer. And you will work with not by hearted style, but with analytical style. You have a problem, you will know how to take your solutions while coding your project. And you can't, there is no standard formula for all your problems. There are many problems and you have got solutions for all your problems. So the approach taken by other institutes and cluster is totally different. Clear? So many people, they will complete JDBC in what? Many institutes, so 2 days. You might have a question why they are doing it in 2 days. You go and ask them why you are not teaching this. They will tell you ulta, what? All this is not required. You are a fresher, you will get the job. You will never get. Actually, if you are getting a job as a fresher, you will be getting on your own skill. Which one? Aptitude skill and all that. But not on technical skill. Based on communication or something, aptitude skill, you will get the job. But not on your technical skill. Okay. And fact is, most of the trainers in the institutes do not know to this level. That is the reason they are not training you. But they will blame it like this. What? Not required. You are fresher. But this is a subject which you should know. Whether it trains it or not, you should know, because these are going to be asked in interview for you. So like this, almost all we have concluded what? JDBC library. Some little topics are there which I will wind up in the next class. All this is mandatory. Okay. And how good you are in JDBC, remember, it will help you in what? The next advanced technologies, Hibernate and all that. So practice all this well. Clear? So finally to conclude, what? JDBC transaction, nothing we do. If you want acid properties, be calm. Just start your transaction, end your transaction. Either by commit or by rollback. All the acid properties will be guaranteed for you. Clear? That's it.